Let's have a look at this indefinite integral. First of all, it is not immediately clear to me that how substitution is gonna be helpful. Then I want to try integration by parts. It's just I need to be very thoughtful when choosing u and v. I don't want to choose u to be, for example, 1 over x minus log x to the power of 2. Because if I do so, that would mean du would be, so the derivative of u would be something like x minus log x to the power of 3 in the end. Right? Then I would have a bunch of terms besides that, making it more complex. But the moment I saw x minus x log square at the bottom, maybe that's the derivative of f of x over gx. F of x over gx, derivative. Here gx might be exactly the bottom, right? X minus log x. Right? What kind of f of x it is. Or maybe just put 1 here. I call that v. I differentiate that one. Because now the bottom would have this square appear here. But here we differentiate this one with negative 1. Right? Negative 1 power. So x minus log x. Power reduced by 1. Power of 2 at the bottom. Differentiate the inside. 1 minus 1 over x. Dx. This time, simplify this a little bit. Right, x times x minus log x squared. Here we have x minus 1. Then we have 1 minus x. So not exactly the same as this one, but I can already rewrite it into, first of all, copy down that one. X times x minus log x squared dx. So like I said, this is already my dv. So when I'm choosing u and v, so that would mean my v would be, so remember here, first let me copy down this one. So when I do this, right, so these terms are the same, it's just I have these extra terms. So that would mean I just need to multiply by their reciprocal. Right, so x times this one. So this obviously u. So that would mean simply du would be just, right, so bottom square, differentiate the top. 1 minus x times log x derivative. Log x, and keep x, differentiate log x, minus 1. So minus 1 plus 1, gone. Right, that's the derivative of the top, the multiply by the bottom, minus, keep the top. So here, x, differentiate the bottom. Negative 1 plus. So here, so negative x times log x, positive x times log x, negative x times log x. So they're gone. Right here, x is right here, but negative log x. Right, so it's x minus log x. That's all I have. Right? That is the here, let me just 1 minus x squared dx. Right, so u du v dv. So I can just rewrite u times v. First of all, u times v. 1 minus x minus log x. Then I have x times 1 minus log x. Right? That's u times v. Right? I say minus integral v du. Okay, so x minus log x times x minus log x, 1 minus x squared dx. Right, so here, they can just cancel. Right, so this is simply here, x minus 1 is the same thing. Right, same thing. X minus 1. So that way I can say antiderivative must be 1 over x minus 1 plus c. But then I should add negative here, right? Because when you differentiate this one, you get negative 1 times negative 1, positive, then 1 over x minus 1 squared, right? Exactly the same thing. So here, but here's a negative sign again. So all you have to do is just say, okay, this will become plus 1 over x minus 1 plus c. I just combine those two. 1 minus x times x minus log x. X minus x times log x. But here you have x minus 1. There you have 1 minus x. You must say minus. Right? Not only that, you say minus, you have to multiply this one. Plus c. But then you have x minus x. They're gone. Right? But then you have minus minus is plus. Right? Then you can extract log x. Right? Extract log x. So 1 minus x. Right? So this is gone. But then 1 minus 1 minus, they can just cancel. Right? So simply, we can just say the antiderivative has to be this one. But of course, we might want to double check by differentiating it. So when you do that, will you immediately have x minus log x square. Differentiate top. Copy down the bottom. Right? Keep the top minus keep the top. Differentiate the bottom. 1 minus 1 over x. Right? What do we have here? Right, so 1 minus log x over x minus log x plus x log x, right? Here they can get then x minus log x squared after you cancel out these one, right? And I believe this is exactly that, right? Exactly the integrand.